The judges, now we're going to have group 11. It's just a matter of basically making a comment on what is your opinion about the presentation in general, and just grade this one from 1 to 5 on the back.
Oh, in the back.
Yeah. If they get anything less than 5, they will have to sign in for senior sign again. But rather than that, we'll scratch.
No. I was okay before that.
No pressure.
Group 11, are you guys ready?
Yes.
Whenever you're ready, start.
So hello, good morning. Hope you're having a good morning. So just real quick, I just want to know how many of us are pet owners. Yeah. So we're dog lovers, and so just the other morning, my dog actually decided he wanted to go out to the restroom just as I was getting ready to head out the door for work. And so I, of course, I had to take him out, and you know, he took care of his business, but unfortunately he took a while, so I was there waiting with him and was late for work. So you know, as pet owners, we don't often realize that there's a lot that goes into the responsibility of owning a pet, such as those little tasks of, you know, taking them out. And so, well, as a team, what we decided to do is tackle that issue, because it's hard to synchronize our schedule with that of a dog, since they're gonna need to go whenever they need to go. And so that's why our design, we decided to go with Smart Pet Door. My name is Adrian Turcios, and I was the lead assembler. This is my colleague Carlos, Jairo, Sergio, and Andres.
Hi, my name is Carlos Castro, and I was part of the research team and the software development. As you can see, in the United States alone, there's a total of 43 million homes that own dogs, a total of 36 million homes that own cats, which average about 1.6 dogs per home and 2.1 cats per home, making it a total of 69 million dogs that are in a home, and 75 million cats that are part of a home as well. As already stated by Adrian, the problem that we have is that we don't have enough time to spend with our pets. That creates a problem, because what we did here is we broke down exactly how much time, or an average of how much time we spend on a daily basis, and we spend about a total of 10 hours at work, 6 hours a week at home. You know, like you just laying around watching movies and you know, eating at home. We spend about 2 hours outside for errands and such things, you know, going to the gym and such. It's about an average of 6 hours of sleep. As you can see, there's not enough time to actually spend with our animals. A trained cat requires a frequency of 4 times to go outside, and a trained dog requires a frequency of 5 times to go outside to take care of their needs. With that being said, if those 6 hours that you spend at home is not enough for that animal to fit its need within those 6 hours. So with that in mind, we created a solution that will take care of that problem, and I will leave you with this.
Okay, thank you, Carlos. My name is Andres Velasquez. I was in the research and development team as well as cost analyst. And as stated, there's not enough time for us to take care of our pets. And so we designed an automated lock-in pet door. So this will allow your pet to enter and exit the house as many times as needed without having to wait several hours. Not having to wait several hours can lead to infections and other health concerns. So this will give you the peace of mind of not having to worry about these certain issues. When designing this pet door, we took into consideration security. It was our biggest concern. As a homeowner, you want to prevent unwanted animals or burglars from being able to enter your home. So an RFID system is installed inside the door that will only unlock when the correct tag is scanned. Now, this is a method used in many buildings where security is a priority. And to further explain the RFID system, we have the following diagram. So the correct tag has been registered in the database. If an incorrect tag is scanned, the door will remain locked. When a correct tag is scanned, the door opens. So I want to demonstrate how we implemented the RFID system. So an incorrect tag is scanned, the buzzer goes off, the door remains locked. Now, as the pet approaches the door, the correct tag is scanned, allowing your pet to enter. Sorry, Barry. No dogs were harmed in our presentation.
Are you sure?
Yes.
No questions. I got all those questions.
So the steps that took us from our initial concepts to what you see here before you can best be broken down into 3 distinct phases. So initially our group had a vision, and we had 3 capabilities in mind. And each one of the prototypes that we developed was a step towards maintaining that vision. So the three capabilities that we were looking for was one, functionality. So at the end of the day, do we have a pet door that works without all the bells and whistles? The second thing that we were looking for was a locking mechanism. So once we've established that there's a door that works, that opens and closes, the locking mechanism is going to allow only specific pets to enter, because again, safety is one of our concerns when designing this project. And then our third one was, how do we allow only one specific pet to come in, as opposed to like a raccoon or like drunk neighbor or something. So our first prototype started off with just conceptual drawings, and then we developed a wooden prototype. And our initial locking mechanism that we thought of was a pulley system that would move our door vertically. So once we had that idea, the first part of our vision was there. We had a door. The second thing that we wanted to implement now was the locking mechanism, and unfortunately, the vertically swinging door didn't work as intended. No, I'm not going to do that. Okay, anyway. So once we did that, we actually decided to look at what was out on the market, and we said, okay, well, what are our competitors offering? So with that in mind, we came up with a second prototype, and we said, okay, well, now we know what to work with. We took the dimensions of a standard size dog, and that's what we used to build a better door. So instead of a wooden prototype, we switched over to using some CAD software to have better control over the fitting, because one of the issues that we saw was that a lot of the competitors, the fitting was an issue. So we ran our prototype. We did some 3D printing. We used PLA filament to take care of just the actual door. Now, as for the locking mechanism, we were thinking about how do we replace the pulleys? So we replaced them. We decided to use a microcontroller. We had two different. We were working with two different microcontrollers. We had a Raspberry Pi, and then we also had an Arduino to take care of the locking mechanism. That worked in conjunction with some motion sensors and some servo motors that we were able to kind of set up, and that kind of got the ball rolling. And from there, we went to our third prototype, which Heido here can tell you all about.
All right, thank you. My name is Heido Valencia. I was the lead designer as well as the cost analyst for the team. Okay, so like our surgeon has stated, like the reason why we didn't go with the vertical unit was because we wanted to have something that was compact. We didn't want to have like a bulky product. So once we already figured out that we wanted to work with 3D printing with the PLA filament, what we decided to do first, since we had the standard dimensions, we decided to run a finite element analysis on our flap door, since it was going to be the only moving component, which was held by the flap bar. So in this one, we did a little research, and we found that around 8 kilopascals is the amount of force that a pet will apply on a door to be able to open it. So we wanted to use the PLA filament because that's a very resistant material, as well as it's very light, so it wouldn't have any problem with the door getting with the dog getting through it. Next, what we wanted to do was design a concept that was very easy to manufacture, very easy to assemble, and something that it was very easy to maintenance as well. And our main focus in my design as well was to have all the components be inside the frame. That way nothing is sticking out. And as you can see, what I wanted to do was break it up into 4 pieces, which was the front frame, the back frame, the flap door, and the flap itself. So as you can see, we have the Arduino here running our code, which we created for this project. We have our breadboard, where we have the circuitry. We have the motion sensor, and we have the servo motors, which activate the flaps. So with this one, it's very easy to assemble, very easy to just go ahead and put in the door. These doors, basically the opening, we made it ourselves, but they sell standard openings in Home Depot or Lowe's or home improvement stores. And this is for a very standard, the back doors. So this is the setup as well. We also included a battery pack in there, which is not shown just because we're going to talk about that in a second. So the main problem with our competitors was that they have a lot of components that are just loose or that are out in the open. So either they get affected by the weather, or they can be affected whenever the dog is coming in too hot, maybe he knocks something down, maybe he bumps into it. So a lot of the reviews that we saw is that people have to be getting replacements for parts. So that way this eliminates all of that because everything is inside, everything is kept safe from the weather and from forces. So our prototype costs around $5,000 and that's including manufacturing costs, design costs, doing the research, doing the coding. That includes the first 2 designs that we did and as much as our labor hour. So after we did a cost analysis, we came out with a figure of around $33.28 if we were to make a bulk production of around 10,000 units, and we will get a profit of around $250,000 if we were to mass produce it and sell it either online through our stores or sell it through our red channel, which could be like PetSmart, the other one, I forgot what it's called. Yeah, yeah, there you go. But we would also like focus on online sales because this is just our base design, but we also want to implement more technology, put a little bit of flavor on people that like to customize their products, and Adrian's going to talk about that.
So as Jairo mentioned, we wanted to have the customer with choices as well. And to add to the aesthetic value, we could add an LCD display on the front panel that could have basic, that would display basic or key functions that the Arduino and the pet door are operating, such as your pet's name. It can indicate when it's a low battery. It can also say when the door is open or when the door is closed. In addition to that, to save as well, we left the power bank here available so you can see that there are multiple outlet sources that you can use. You can use the power bank, or you can keep the battery pack inside the panel, or you can actually connect it to a wall outlet or another power source. But the most fuel efficient one, the most energy efficient one will be the solar panel that could be installed upon request.
Now, although we have a full functioning product, there are a few innovations that our team is working on. One of those is an application that can be installed in both Android and Apple products. And what this application will do is it will give you access to entry and exit times, as well as alerts if your pet has been gone for too long. So if your pet has been gone for over 30 minutes, you might want to check on him and make sure that he's safe, he didn't run away. Another feature that we're very excited about is a facial recognition feature. So the way this works is there will be a camera installed in front of the door, and it'll scan the pet's face. It will match it with a few photos in our database. Whenever it's matched, the door will unlock, allowing him to go inside. Now, the coding currently works for one specific dog, so as soon as the coding is fully developed, it's going to be implemented, we will have a facial recognition smart pet door. And it's time for Barry to go out, so we will open the floor to any questions you may have.
Makes you want to get a dog.
You can pan and shoot. Give me the car, we'll install it though.
First question?
Yes, first and foremost, I think that's a fabulous idea. I have a few pets at home. I definitely would be interested in purchasing something like this. So that's a great job on that, guys. So a couple of questions. I do have a couple of pets that range from big size, big pit bull all the way down to a Chihuahua. So one of the questions I have, what would you do, for example, dogs are kind of hard to train to hear sound. They're all going to want to stampede through the door at once. How would you control that?
I'll take that one. For that one, what we would do is we could put like if you have a lot of pets, we could program several RFIDs for each pet. Okay. But also, like if they all want to go in at the same time, we could also have a program to stay open a little longer. That way, like all the dogs can go in, and then after that, like the flap will close. Okay. That way, it doesn't close prematurely, and it just depends on how many dogs you got, and how much you think it depends on
the frequency that they
on the frequency. Yeah, like how many dogs you think like, or how long you think it would take them. But all of that can be customizable because all the code we wrote ourselves, so we have control of that.
Okay. Yeah, I'll let them ask. I got a few questions. So I'll go ahead.
So quickly, I'm not familiar with the pet doors or anything like that, but how strong is that lock? I'm thinking, can somebody come from the outside and just kick that door and then enter the house?
Not really, because if you notice, it's pretty solid.
But if you kick it, very solid.
Oh,
it opens.
Let's try it.
I want to kick it.
Well, want to kick it, but we don't want to risk it right now.
So then my question.
We'll show you how for the Expo.
Exactly. So then my question or my comment, maybe to think in the future. I never leave my house without activating the alarm system.
Right.
Okay.
No? So if I'm going to have my dog walking inside the house,
Right.
maybe I can leave it in stay mode.
Right. Well, part of that, as we stated on the future add-ons that we have, is to interface this device. Arduino can actually be interfaced with Alexa. So if you have an Alexa program at home, Alexa can lock your doors, and it can interface with this Arduino to unlock to either just turn it off and not allow any power into it, or just completely continue the actual power and let your dogs inside and out.
Yeah, but it's not only like lock the doors; it's also to have the alarm.
Yeah, of course, yeah. But you basically give the command to Alexa,
Yeah.
and you tell Alexa, lock my house, and Alexa will activate your alarm at your house. And once the interface is connected of the Arduino with Alexa, it would automatically not turn this off as well.
Yes.
Yeah, if I may add something, I think that is a great idea to have it connected to the alarm, because we did design it in mind like a regular force is like around 10 kilopascals. Just if a dog just coming in and like he just slams into it, it'll hold. But if somebody really wants to get into your house, they'll probably get in anyway. So. Yeah. So I mean, but that's a great idea to incorporate like the system to be connected to the alarm.
In our FBA analysis, we also found that like a dog on average can apply 600 pounds of force. So it can withstand about 600 pounds of force, which is I guess I don't know what to compare to, but that's all I know.
Other thing what you can think of is now this is 3D printed with PLA.
Right.
Right.
Your future, goal might be to get it injection molded.
No,
Yes.
this is just our prototype. So our final
Yes.
design is an injection molded.
Yeah, part of the cost analysis that we did, we also did visit that point as well, is to use the injection point, the
So all
injection
our final costs
manufacturer.
are with that already in mind.
So
Yes.
you might think of reinforcing the door with some metal inserts,
Right.
or some carbon fiber,
Right.
if that fits the budget.
Yeah.
Because right now it's with 3D printing, it's like $5,000.
Yeah.
Yeah.
Will it still
no,
be
no.
cost effective? I mean, I know you're using PLA for your prototype, but will it still be cost effective?
No, the numbers there are with our injection molded metal.
Yeah, the cost analysis is with a sheet metal and it's foam insulated.
Okay.
So saying
And it's taking into account if we were to buy a bulk of 10,000, we were to mass produce a bulk of 10,000. That's how we base our numbers on.
And this fits any door?
So we got
I mean, like,
there's three sizes. There's
So-
small, medium, and large. So this is what you're looking at the medium sized door.
So, Billy, you said that already. In Lowe's, you can buy a door that already has a hole. So part of our research was to make a standard sizes. So that way, whenever if you want to do what's it called, a DIY at home, you could look at the instructions that we will provide to you to see how big the dimensions of the hole needs to be. 1, 2, if you just want to buy the door separately at Lowe's or at Home Depot, it will fit those dimensions. So we, as the average size of a dog tends to be more on the medium size, so that's why we decided to just display the medium size. But of course, if needed to be increased the ranges, the dimensions of it could be done.
Oh, okay. So what is the conventional material that has been used currently by the competitors?
So some of them use just like plastic. So
Like
like
what
for example,
kind of?
PetSafe. I'm not sure because they don't specify on like their website. So all I know is it's like it's a plastic door. I'm guessing. Like, I don't know.
There's other ones that the other ones that are not automated. The normal ones that are not automated, they're just a piece of rubber basically that would just allow the dog to come in and come back inside. But that creates a problem of allowing other animals to come into your home. Meaning rats, roaches, and so on. So you don't want that. And with this, we took that into consideration that it wouldn't allow it to come inside.
Did you do some?
I guess.
Oh, go ahead.
I guess one thing I'd like to see discussed a little more is this type of market is pretty saturated, right?
Right.
So you mentioned, I'd like to see more discussion on what separates your design from your competitors, because you mentioned something about how not everything is enclosed within the
Right.
case, but you know, when I look out, I've looked at these products online, I don't see exposed wires or anything. Everything's enclosed in all of them, it seems. So what's the difference?
Yeah, it's not just the wires. Sometimes they have other little latches, or they have little components that are just outside. So we saw a couple of those, and we figured that if a dog was just running or something happened, maybe you accidentally dropped something like really close to it, that could always get knocked off. And a lot of the reviews that we saw was that some of these components, like it's little components, maybe not the wires, but like these little components, once they fell off, they have to get a replacement, and sometimes they don't have a replacement for it. So our main focus was to just have everything in there, and then not only is it like just look better, it's very neat and it's easy to clean. Like if you ever get like some gunk on it, and then that way you don't have to be doing anything.
Additionally, what kind of separated us was the latches as well. That in case you, for example, decided to use the wall outlet for your source, and you accidentally left it disconnected, like as she mentioned earlier, you know, she wanted to connect it to the alarm and all that. In case there was no power, your dog would still be able to exit. If the latches were inside, or they used the magnet like the other competitors, your dog may not be able to exit or come back in on its own, because you have to have it plugged in or something like that. So ours, at least your dog can still go outside. And if you feel safe for your dog to be outside for the rest of the day, then you could leave him out there and he won't be able to come back in, or you can still let him in. But at least you have that kind of peace of mind that in case say the lights go out here in Houston, it rains, and then sometimes the lights go out, then your dog can still go outside. I don't know why he would want to in the rain, but you know, he'd have that option. And then at least you know he's outside and you can come back in. So that was one of the reasons.
I'd like to add more to that point. Another part that we saw and that we stated too is that we wanted to provide safety to you and to your pet as well. And a lot of the equipment that's being sold online, it kind of relates to an RFID tag, but it's power. So technically they try to power this. So what that causes is that if it gets wet, the acid on it ends up burning your dog. So we didn't want to power anything around the dog. We didn't want any current or electricity to be around your dog. So we established everything to be on this part, and that's one of our biggest separators with our competitors, is that they want the dog to be the one that's holding the power, you know, close to their necks to basically allow them in or out. In our case, the dog approaches the door, and it reads our RFID tag, and the system itself turns on. It doesn't need, this is basically power.
That doesn't conflict the current.
Yeah. Yes.
So we have the A-Leaf Girls in STEM program in A-Leaf. We have 4th, 5th, and 6th graders that we really are trying to inspire to get to engineering or in engineering. So you mentioned 3D printing. Tell me 2 ways you use 3D printing. So in 6th grade we have coding across platforms, and we have 3D printing. So tell me 2 ways you use 3D printing in this, because I know our girls are going to love this project.
Right. Well, the first thing that we did was, we designed it using Inventor. Well, I mean, I use Inventor. He used Creo. We used different programs to create it. And then basically we exported the STL file. So I mean, I don't know what kind of printers y'all have. Like, is it MakerBot?
No, we don't have MakerBot. We have what's Cura. The software is Cura.
I think it's open source. Yeah.
Yeah, we can do that.
No, wait. I will remember it.
Okay.
It's my program.
But at any rate, as long as you, I don't know what kind of design program you guys are using, but as long as you can export the FTL file, it can be read by MakerBot or any open source.
So because we use separate different CAD programs, so all we did is save all those files to STL.
Ultimaker. That's our
Okay. Oh, you know, I think that might be the one in THQ, because we did go to, which one was the one down to?
TXRX?
TXRX.
Yes.
Yeah, that's the same one. Yeah.
We work with that.
Okay.
Did you have it? You just said you had 2 questions. Was that it?
No. So that one, I think we're trying to establish really relevance for girls, like because with girls, it has to be meaningful and relevant to them.
Well, this is I think this is the complete package, because not only are you working with the 3D printing, we're also work with code. So there's different levels of code that we're involved with this. Yes. Like the first one is the Arduino that we're using, which is
we're not quite to Arduino.
Okay, but even then, I feel like that was like something that could be easily learned. You know, if you're trying to go the education route, if you want something really heavy, the facial recognition one, that code was a pain in the butt.
I think also like for example, like 6th graders or middle school, Creo is like a great program to learn. It's actually like really easy to like.
Say that one more time.
Creo.
Pro engineers.
So that one is really easy.
It's
to pick
free
up.
too for students.
It is free for students. And about the 3D printing too, we use white filament, but you can actually customize it. You can use blue, green, pink, yellow,
whatever the person's color.
I know, like at that point, you're trying to be like an individual. Whatever you want.
So in 5 years, I should see more girls in engineering.
Hopefully, you know what? Hopefully, that
Well, that-
actually should be, you know, hopefully it's a good
That's
thing.
actually
that
the
can happen.
foundation
And then
right there.
not only
Because
that-
if they start around there and
Yes.
they're around this age and working,
It would
with
make it
them,
a lot easier for them. They would even come with brighter ideas
Yeah.
into this market. if
Not
they
only
come
you
in.
can get them to work with circuits too, because that was like
Yes.
one of the things that we were working. You know, we're all mechanical engineers, so like we hadn't seen circuits in a while. So
Or we grab it.
We try to incorporate as
Program-
much as
computer
we
program.
learn, like during the program, which is the CAD programs, the circuits, the coding, which they don't really
Software.
teach us, but we learn a little bit.
I kind of had to learn a lot of the coding stuff on the fly. Yeah.
Okay, one question on the basic mechanism. So
Right.
a pet walks up and it turns on the motor, right?
Right.
How long does the motor stay on?
You could, it depends, that goes back to his question. So if your pet is a slow walker, like his pet is, you could actually change that. Right now we have it set for 6 seconds. But if you need to increase the time, because we were the ones who created the code, we can actually change that a little bit. And we can change
We
it
can
to
ship
like,
it out if
to like a minute if you even want.
What if at that time the pet is still standing there? Does it go through another cycle?
What do you mean?
Wait,
Well,
Yeah,
as long as it's within
yeah.
the range, yeah. Because what'll happen? So what happens is when it's scanned, the latches will open and then it gains entry. But if the dog just stays there, like afterwards it's gonna close. And if the dog is still within the range, or the cat or whatever, if it's still within the range, it'll do it again.
Okay, so here's the question.
Okay.
Let's say it's a sunny day out
Okay.
and my cat wanders outside and then goes outside, sees it's a sunny day, and my cat likes to sit in the sun. It lays down and takes a nap all afternoon in the bright sun right in front of the door. And your door is just going for hours.
That one we do have like if that were to happen, he would actually have to be almost laying on top of it because we did take that into account. We have made it that way. The range is not too much. The range is not too much because that's what we were thinking too. Like if a dog is just walking by, we don't want that to like go off and like open. So the range is about
And that was one of the competitors. So I looked at reviews. Some of the competitors said my dog he runs by and the door's just opening and closing all day. Sometimes they malfunction. So again, back to what they said, we kept that range at a little bit shorter, just because we don't want that same issue to happen. We wanted to take.
I'd worry about the motor getting worn out, but the
Yeah,
cat
no.
sleeping in front of the door.
Yeah, you have to like really like sleeping almost.
But
on
that's
top of
very
it.
valid because my dog used to do that. Just lay in front of the door because it's where the air from the inside was coming outside.
Yeah.
As it was outside.
So right there.
So it'll be a little hard for sure. There'll
Okay,
be
so
some distance.
maybe what we'll do is we'll implement like a little fan that we're like.
Connected to Alexa too.
Next to the door, so it
Yeah,
is
it's like
clear
Somewhere
way.
here is like cool your dog down.
Did you test the system with Wear Pet?
I'm sorry?
Did you test the system with Wear Pet?
I try to go in, but I couldn't.
Well, so like the thing about the dogs, is that they learn things so quickly that you think that it takes a long time to train, but once they know where the door opens, the crack, that's where they go to always. So
Yeah.
usually they'll know that when the little door goes up, the flaps, the hinges, they go in. So really it was more of a
we
wanted
made
to be
we made the
safe.
noise too, so that way we included the noise in there too, so that way the dog would sort of keep that in mind too. Either scare him off, to not keep pushing in, or to kind of alert him that that's basically the time that he can come in.
We did test it with his dog though, but like if we had brought him here, he'd be like just running all around. So that's why we have Barry, our
It's good.
It's a
very
educated pet.
The whole ring thing, got a little padlock thing going
And the
on.
only pet allowed in the campus.
One final question. What if I don't want my cat going outside at night?
Oh, you can turn it off.
Oh, but there's an off switch?
Yes,
Okay.
yeah. I mean, once you
unplug
just connect, like in this case, we have it connected to the power bank. But once you disconnect it,
Disconnected,
it's nothing. It's at this point, it's dead. And even if somebody else, would try to, gain access to your house, it still will be locked. Any more questions?
Yeah, I got a couple more. So as the door kind of heats up, right, especially plastic and electronics has a tendency to dissipate a smell.
Right.
Especially with some of the other more sensitive dogs like a beagle, which I have.
Oh, okay.
What are some of the chew-proof materials that you guys have looked into to
Okay,
kind of
so-
eliminate that?
So for that, based on the, for the prototype itself, we needed something that would be cheaper for us to produce. You know,
Sure,
here it's good.
right.
But
What's your
for the
ideal
actual idea
material?
that we would use, we wanted to incorporate a foam that will protect it, that
Okay.
protect the electrical components. A foam that would not react with the actual electricity in case there's a short circuit in it, and also create different layers, so that way it's not just metal, because metal tends to heat up, and if that's heating up around it, it could create an environment inside that could actually, you know, end up burning the equipment. So we wanted the idea was to put a little bit different layers with it. So basically testing all the different materials that could try to perform well, as well as the foam. The idea that we did a little bit of research on that, and we found some fire retardant foams.
Okay.
And that would, you know, in case of an actual fire was to happen, it wouldn't allow it to spread through it.
Okay.
Just to kind of add on to that, one of the things that we also saw from our competitors was that, like, not only that, there was a lot of heat loss coming in from the doors because the way that they designed it, you know, a lot of air was escaping. So the foam kind of acts as kind of like an insulator as well. So, you know, if you're worried about your energy bill, you know, it's something.
Yeah.
Yeah, what we would do too is like on the design, we're also did like for the cost analysis, it would be like sheet metal, like with the foam filling. But also we will have thermal breaks. That way, like there's never like metal on metal contact, or it keeps the hot metal. Like for example, I know Houston gets really hot, so it keeps the outside when it gets really hot from like transferring that heat, from that heat transfer going into the actual system.
And as you can see, the reason why as you can see the space in here that we took into account in the design was to incorporate that idea too. So anything that we, you know, for future designs, for more, you know, I guess more solid concepts that we could design. Of course, you know, that's out of our budget range to make it. But for those ideas, if we were to send this design to an actual manufacturer, they would actually be able to produce it and include all of the foams, all of that equipment with it, and still keep the material inside. The component is still inside the door, and, you know, away from you know, the rain damaging your equipment, or, you know, your pet just brushing on top of it and just killing it.
You should apply for like a B Corp, and like whatever you generate, like part of it goes to SHPE.
Oh, okay.
So kind of like GoFundMe, kind of like that.
It's kind of like, you know how Palms was built.
Oh, yeah. Oh, okay.
Yeah,
I did not know that.
I
did not. Thank you for that idea. Thank you.
So sorry, I have like maybe
Sure.
two more questions.
That's fine. Shoot it.
So one of the things, again, for those of us who have multiple dogs and sizes, what's your effective scan angle? Because a small dog isn't going to be able to trigger something if it's geared towards the big dog. Is there like a scan angle range on these tags that you guys could kind of implement?
Yeah, on those, what we try to do is have for example, this is just for medium, to small to medium size dogs.
Okay.
So what we would try to make like an online page where you can have like a customizable unit, where you could say you have small dogs and big dogs. So maybe for like really big dogs, maybe have two sets of motors. Yeah, two sets of RFIDs. That way, like a flap is basically, there's like a little flap inside a big flap. So if you have a small dog, the small dog can still go through the big flap, and if you got the big dog, it'll activate the big flap.
Okay.
Not only
But
that,
is there an effective angle that you guys calculated for your range?
Well, this tends to act as a, I believe it's from where it is, it's at a 45-degree angle. But it also depends on the range of the distance that's away. So that can be increased as well. But if we were to switch the RFID to any other point, if you were to see it this way, like this, it would basically be triggered in this manner.
Not only
In this
that,
direction.
and the actual scanners are pretty inexpensive. So, like, if anything, we could add, you know, an additional sensor.
We would just have to increase the size of the breadboard so that way, you know, we're not overpowering and burning the equipment.
Like at one point, because the range of the sensor was actually one of our biggest concerns towards the end of the project, and I was actually toying around with like a little antenna that work. So basically a bunch of coils that we can actually wrap around here. So that didn't make it to the end, but
Yeah.
it's
Like I said,
something that
yeah,
could be in the
could
works.
be.
You know, given a little more time.
Actually, I'm sorry.
Yeah, go for it.
Yeah, to fully answer your question, we don't really have like a set angle right now.
Okay.
But we were thinking about like your different sizes of dogs, small, medium, large.
I mean, that'd be one of the things
Yeah.
I'd look for.
And I also have like big dogs and little dogs.
Yeah.
And what I know is that the little ones are quicker than the big one. So sometimes, you know, they all kind of follow like one path. So
Yeah.
you know, they'll once they figure out where it's going, like that's where they're gonna keep going to. You know, where it's triggering.
Okay.
So
So,
typically they'll follow it.
Yeah, one final question, guys, and then thank you for taking these, I appreciate it.
Thank you for your questions and for
So we didn't
time.
really get into any real technical data, right? We didn't
Okay.
really see any drawings. So your FEA analysis was kind of, it was a little confusing. So we didn't really see where the main fixture impact is, what part of the door is intended to stay static. We didn't see an impact zone, and I didn't see really where these stresses are intended to be generated from. So can you show me on the door, what is the part that would fail first on that door if a dog, because I'll tell you right now, if my dog hears a raccoon or something, he's gonna wanna charge that thing.
Okay, so, you wanna go?
Where
So-
would your weakest point?
So the weakest point that it's that it would be because of the cross-section area
Mhm.
would be actually somewhere in this area that we were thinking about.
Okay.
And based on our analysis, it also happened there. Also in our analysis, it stated. Let me back up on this part. When we did the FEA analysis, we didn't specify the force on one time because we imagined, you know, that if the dog would try to come in and he didn't come in, he would try to, you know, keep going in. So he wouldn't apply the force at one specific point. He would basically, you know, tackling the whole part, the whole door itself. So we did the FEA forces throughout the door. So the weakest point that we found was actually on the hinges. That's the part that will be affected the most for friction part.
Okay.
I'm sorry. I mean the bar. Yes. I'm sorry. Having a little time. The actual hinges itself, it reinforces the momentum that to withstand that force.
Okay.
So this part here, we first assumed that this would be the weakest part because the latches themselves, they wouldn't be strong enough to hold it. However, based on the FEA analysis, if we found that some of the weakest point would be here actually on this on the actual bar, which it could be the part that it could end up breaking first.
Okay.
However, again, because we didn't want to risk it.
Okay, so
and out of our budget to redo
when you did your FEA analysis, did you analyze for displacement? Did you analyze von
We did.
Mises stress? What
We did.
did you get? What was your target?
Did you?
No, we didn't include all of them because we didn't want to make the presentation too long. But
Okay, which one do you think you would want to do?
Displacement would be the one that we would need to do because that would
Okay.
show the actual deformation that could occur on a door.
Okay.
That's the one that we would see the most.
Okay. Would you not be interested in your yield if that thing would crack? Because you know
We,
plastic, right?
well,
is-
part of the displacement analysis on it, and I wish we would have had it, but let me try to go back on it to show you that part. This is the pressure on it.
Is
But
that von Mises though?
I'm sorry.
That's
Yes,
von
this is von
Mises
Mises,
stress, right?
yes.
Okay.
So as you can see, we basically found that most of it will be here. Oh, sorry. It just died.
They used to do that to me too when I did the presentation on there. So.
We are very pet oriented, as you can tell. And it's crawfish season too.
It looks like.
Yeah, we're
Sorry
supposed to
about
see
that.
I'm glad I don't have anything else.
I'm not sure why it's not showing.
That's okay. I just kind of wanted to see what your guys' intent was. What data you.
But yes, but okay. Back to this part. Try that in the con. So the SolidWorks, I set a limitation to be basically here.
Okay.
To basically be around 8.5 megapascals.
Why is that?
I'm sorry?
Why is that?
Oh,
What was your safety
that was
factor?
I can't remember the actual number of the yield point of the material,
Okay.
but SolidWorks gives you an advice as to what could be the breaking point on it.
Mm.
So
Sure,
so
so
I
trying
said
to optimize
so I
it.
said basically the middle point to be. As you can see, applying the 8 kilopascals on it, it would basically take about 1.5 a little bit more than 1.5 megapascals above that to break it. Our point here was basically a point that we wanted to target. On the displacement, the one that I just say, that it would be beneficial to show. And that one, what it would do, it would show you the actual deformation that is occurring on it if force would be applied.
Right.
So even though this is the weakest point that where most of the forces are being held, on the deformation part, this bottom part, if there's no hinges attached to it, it would be the part where it would be the most affected.
Okay.
So on that question, the actual I think you said that you wanted to see the deflection of it as well. So that analysis basically gave us that, and if the full force was applied to it, then it would actually bend at that point, and you could create damage. But
Okay, so what was your safety factor on your material?
I believe that was a factor of 3 or
You know, honestly,
can't remember.
yeah,
That's on the
honestly, I
report. It's on the
can't
report.
We
Can't
don't have it
remember.
on the report, but I
Can't remember. I'm sorry.
No, it's okay. Thank you. Thank you. I appreciate that.
Thank you. Thank you for the.
Considering now that we are on the FEA, what I might suggest is if you are designing the cross section
Right.
of this dome, instead of giving it a uniform cross section, you might actually change the cross section throughout. Because when you inject a material, there are different rheology of polymer that
Right.
goes into injection molding. Another thing that you can do as a design point of view is that you can actually introduce the ribs, vertical and horizontal, that can increase the strength, inherent strength of that material.
Like a
So that's
thermoplastic as well.
Yeah.
Oh,
Because it gets like 300 degrees in the summer, right? So it'll expand a little bit more, right?
Right.
So.
Right.
But I don't have any more questions, guys. I mean, I'd be interested in buying that.
We'll send you a note. If you give us a 10, we can take it.
One final question. What if my pet is a 12-foot snake?
Oh, man.
No, this is only
You shouldn't let her-
one.
Swimming outside.
How am I going to put the collar